this should work. All right, so what I'm doing is getting this over here to over here and testing this out. This is attempt 20, I believe. So yeah, I'm gonna use a Jamboard, but I use a Jamboard for the graph, like like these plot, like these setback grounds. But afterwards, I screenshot it and use snip because it's much more cleaner lines than because if you look at it, it's like a little wavy over here. I don't really like using this. So it's always so wavy. Anyways, I don't know why. It might be because of my what I use as a, a pen. But yeah. Anyway, so this is Coulomb's law. So yes, the general idea of Coulomb's law is that we have no, we have this formula right over here. Let me grab that formula by using snip just to grab it in and explain what my denotations are because it might not make sense otherwise. So let me save that. Let me copy it actually because it's easier, and then be it here. Okay, there we go. That's snipped in. So over here, this symbol means that this is subset. Uh, subset. And for some reason, Jamboard is lagging behind. Whatever. This should have KB actually. Uh, It doesn't matter because it's KB has so many definitions. Later on, KB has a definition of something in entropy later for some reason. That's a subset. This is our EV, otherwise known as our unit vector. Unit vector is helpful sometimes. It's questionable if it's actually helpful, but subset means that this is the prime equation. This is like the equation that this left equation is derived from. Basically, if the the charges were like this, was basically like this format over here, then it would be this over here because there's no reason to go and use the unit vector. But if it's an angle like this over here, where we have an angle, you need to use a unit vector to figure things out. Um, and then it makes sense. What you're basically doing here is grabbing this over here and then transposing it into here, transposing this over here like this, getting the two. So this goes over here, and then you're getting the y and x over here, and then you are getting the two forces, the F forces, and then you are using the knowledge of the displace the angle to get the vector. Now, technically, you're supposed to put this in polar form. I don't know why, but no professor cares about it, from my experience. So fuck it, don't do it. It's a waste of time, and also this is a vector anyway. So why would I want to transfer it back? I have no idea. My high school teacher said that they would care. But it turns out they don't care. They actually don't like it. So they just want you to leave it this way, which is fine. I don't think you need to change anything more than that. So next thing we do, um, well, I do need to explain point charges a little bit more. You can look at that question later, but we need to look at why it's it's because this one is like this, so I need to do it like this to actually grab it. Yep, some of them are like that. Because I made a mistake when I said when I made this, I forgot to put 1D polarized. So here, so this is basically the most simplest version where we don't have any EV change other than it's a unit vector change. Unit vector changes are awesome because they're harder and they're not harder, they're just more, or let's say like one more step and it does seem to be more valuable with the superposition later on, which we could talk about superposition soon. Um, so yeah, unit vector, you're displacing it here, but this in this case the unit vector doesn't matter because it's like left or right. Um, so point charges are basically small objects that are so small you can consider them a point. That's basically what point charges are, and that's what you should consider it. So basically, what I'm saying is that if they're super, super, super small point charges, you can basically consider it to be a. So, how do you explain it very carefully? You see these two objects. Imagine them in the empty void of space, and they were this small, and then it might have been like this is a law. This is like a plate, and this is like a grate or something, but they're an empty space, and then they're so far away that you can consider them that's like basically point charges. That's pretty much the best explanation I can think of. Uh, all right, the electric field we can talk about later. Supercharges next. I do need to do more of these derivatizations. I'm not done with this. I have to do electric field of a single line, which is basically doing the same thing here, where you just sign theta over here, where you actually change it to the sign, change it to box form. Oh, actually, I got something wrong there. Ooh, that is wrong. You could go polar form with Jacob matrix. No, you can't. I mean, you could. It's a change of polar coordinates um, um, from. You could technically change it to polar form, but I wouldn't recommend it because it would be way harder. Because what was happening is you basically need to do something like get a polar form like this. So you would need to probably change it to um, um, cylinder coordinates maybe, but then you have to calculate the bound to be 2 pi and then to 0 on one of them because you're going this way, and then you have to figure out the angle over here. Yeah, I actually don't think. I think that's possible actually. Uh, oh, yeah, that should be possible. Oh, I thought it was impossible, but it is possible. I just don't like to do it. Don't want to do it, and let's just move on. Hmm. Yeah, let's put the background to this. I don't like this. All right. So over here we have superposition. Basically, you could theoretically, if you wanted to, make one of them like transpose it up. Then it'll go over here. The distance over here is r, but you have to change everything to that mode. So it might be not advantageous for you to switch everything because you have to switch it like this if that happened, and it's not worth it. So yeah, so the easiest way to fix that problem is just get this idea of e vector unit vectors because they make it so much simpler and able to do different point masses very easily, as you can see in the following. I do want to make a video on this over here, and then I'm gonna send it to a professor and see if it's correct. 'Cause I have no idea.